Oh, now let's take a look at this example. Air is escaping from a spherical balloon at the rate of 2 centimeter cube per minute. So it means if you have a balloon, let's draw it, and the air is escaping, right? The air is the volume, so we call this is V. Escaping is mean the volume of the balloon will be decreased, so it's going to be negative. So our dV over dt will be negative 2 centimeter cube per minute. Okay, so make sure you know the keyword. And then the question asks, oh, how fast the surface area shrink when the radius is 1. So the surface area, which is the A, how fast does it shrink when the radius is equal to 1? Okay, so look like this problem, you have two things that you have to relate it. You have the volume and you have the area. So let's write down the equation, the related equation first. The volume of the V is 4 pi r cube over 3, right? This is the volume of the V. So we go back to here. Volume is 4 pi r cube over 3. Okay, and then we're gonna also write down the area because it's gonna relate two things. So the area of the cube is 4 pi r squared. So 4 pi r squared, not the area of the cube, the area of the sphere. And then now we're gonna have to take the derivative on both of this equation. So derivative of v over t, dv over dt is 4/3 pi. Bring down the power, we have 3r squared dr over dt. And then putting anything that we have the volume is -2, which is 3 and 3 cancel out. So you have 4 pi r is 1 square. And do we have dr dt? We don't have dr dt, so we have to leave it at what it is. And then from that, can we isolate for dr over dt? Yes, we can divide both sides by 4 pi. And that is -2 over 4 pi, which is dr over dt. Okay, so from the volume formula, we got dr over dt, but this is not what we want. We want the derivative of A with respect to t. So we're gonna have to do the derivative of the surface area. So dA over dt will equal to 4 pi. It's a constant coefficient. Bring down the 2, we have 2r, and then dr over dt. Now, plotting anything that we have 8 pi. The radius is 1, just 1. And then the dr over dt, lucky that we already find that above here. So we're going to have -2 over 4 pi. Simplify everything, we have 2, and then this is going to be -4. Okay, so it means when the air is escaping from the spherical balloon, at this rate, the surface area is also shrink. The area is shrink at the rate of 4, shrinking at the rate of 4 centimeter square per minute. Okay, this is square because we talk about the area. All right,